Hello friends, welcome to our Hariharan Express channel. Today I will discuss regarding on design arithmetic logic shift unity with logical circuits and its corresponding functional table. Okay. Previously individual shift units we have already discussed. Okay. So previously we have already discussed arithmetic micro operations, logic operations, some shift operations, but separately we discuss that part. So today I will discuss regarding on how three unit, that is arithmetic, logic and shift unit, three units made in a single stage, that is a single stage of this three unit we have to design. That means logical circuits, we have to design a logical circuits based on the these three unit design. Okay, that design need to explain how to design each individual components, means arithmetic component, a logic component and a shift component, how it will work according to our design. Okay, in a single stage. Different stages we have already discussed, but how it is defined through single stage. Another concept is there, like whenever you go through this single stage, normally how many bits we will consider. Okay, any bits we can consider, doesn't matter. Suppose two data, suppose AI data or BI data, AI data doesn't matter. Whatever the data we can take it, maybe 4 bit, 8 bit, doesn't matter. Okay. And whenever we go through that design, certain number of multiplexers or selection variable we have to take it. Okay. So the since it has three components, one component for arithmetic, another logic, another shift. Okay. So two component will define for arithmetic or logic, by which component will activate, that will decided by certain that is a variable, selection variable. We will consider certain selection variable like S0, S1 or like this. Selection value, certain selection variable we define for, that is these two components. Okay, one for either arithmetic, another for another that is logic. For example, suppose S0, S1. Okay, S0, S1 two component, they will decide for this one for arithmetic, another for logic. They will decide, and how to decide I will show you based on the certain that is design of that. And whenever you go through that is arithmetic logic, that will be defined through certain variable, means inputs. One is AI, another is BI, means two input will consider for both arithmetic as well as logic. Okay, because arithmetic addition, subtraction or whatever the number of operations will consider, those operations defined through these two variables. Okay, two inputs, that is variable, that is actually two inputs, AI and BI. That is also defined for the logic. That two inputs also defined for logic. For example, suppose arithmetic consider, then what happens? Very simple way we can define AI plus BI or AI minus BI. Okay, different way, or AI increment or something. Okay, like this we can define different arithmetic operation we can define through these two inputs. If we go through logic, similarly we can go through, that is a logic like AI and BI. We can write, no problem. Depend on the same inputs, but a different operation we can consider. Okay, whenever we go through this arithmetic operation, then definitely some carry out data we can get it. Like AI plus BI, when add, then definitely suppose some carry out data we can get it. Okay. for arithmetic operation. But here what happens, carry out data cannot be possible for logic unit. Only simple what is the logical value of 2 data. Okay, in that case Cin not required, because whenever you design I will explain at that time Cin part is not required. Okay, these are the arithmetic and logic. Another concept is shift. Shift data whenever we will consider, then that data taking the another output very simple way, ai minus 1, ai plus 1. Okay, means another not same, because some complexity will occur. For the reason we will take that is ai minus 1 and ai plus 1. 2 data we will consider. In that case it may be considered left shift or right shift from these 2 data. Okay, based on these inputs we will define, and whenever you go through this shift, then what happens, another selection variable we will consider, like here suppose S0 S1 for arithmetic and logic, then S2 and S3 consider for that is a left shift or right shift, like this we can consider. Okay, we will see whenever you design how many variables, selection of variable you consider, what are the inputs we will consider for either arithmetic or logic. Okay, these are the inputs to define or design that arithmetic logic shift unit in a single stage logic circuits. Okay, and another part is also there. Whenever you go through that, they will choose actually arithmetic or logic as per this variable. Okay, S0 and S1, and another S3 and S2 or S3 defined for only shift. So we have to remember, if you arithmetic or logic circuit, then we will go through this 2 selection of variable S0 S1, and a shift shift unit suppose we design, then we go through selection of variable S2 and S3. Based on that total single stage design we will consider. We have to design single stage for with the help of this arithmetic, logic and shift unit. Okay, now we will design that part, how it is designed. So here very simple way we will consider. The part is very simple way I will show you. So here is a 2 part. One is that is arithmetic circuit. That one stage of arithmetic circuit I will tell you, then I can understand. That is one stage of arithmetic circuit. Arithmetic circuit. It is why it is I wrote one stage, because here all kind of small components are there. So single stage we will consider one stage arithmetic circuit. Another part here, there is one stage of logic circuit. One stage of logic circuit. So one stage of logic circuit, why it is considered? Because the number of logics are there, and or that is XOR, not, this is defined here. Okay, now we will see some components. One output from here, another output from here. What are the inputs? Okay, from this I told previously that is either choose this one or this one. It is selected by 2 variable or 2 selection variable. One is S0 and S1. So 4 selection variable we consider: S0, S1, S2, S3. 2 selection variable for that is either this one or that. 2 selection variable. See, okay, 2 selection variable we define here like this. another it is two part, two value, two selection variable, either this one or this one. I will show you how it is defined or designed. Okay. And another is you see two variable or two inputs we will provide both, that is arithmetic circuit and another logic circuits. That variable is we can write here is AI BI, that inputs we will provide to logic circuits and also this. Okay, this two, one AI BI go inputs are that is consider the inputs for arithmetic circuit. AI BI also consider for one stage logic circuit. Both this input we will provide. After that, definitely some output we can get it here. Some output like suppose DS or some output we can take it here also. E. Okay. Here a DS or ES, as you like it, you can tell any things. But here another multiplexers also we consider for one multiplexer, then it will choose that data. It will choose that data. And another is two selector also there, here two selector is there, they will choose here very simple way that selection, here select, and this data, particularly this arithmetic data connect to here, that is 0, and this logical data connect to 1. Okay. Since S2 and S3, this two variable selection of variable will consider, then what happens? 4 position of data we can take it. Another is 2, another is 3, and that 2, one is 2 and 3. We see here we consider, I told previously, A I minus 1, A I plus 1. Okay, that data consider for here. Okay, that is here shift right, another is shift left. I will show you, then you can understand. Here is a shift right, shift right, shift left. Okay, shift left. And what are the output we can get from here? Then one output we can get, that is Fi. Okay, that Fi we can get from this single stage arithmetic logic unit. We can tell this total stage is one stage. We can tell total set is one stage of arithmetic, logic and sheet. Okay, this component total defined in this way, very simple way defined in this way. Okay, so it is one that is one stage of a arithmetic circuit, here one stage of a logic circuit, here that is some that is a multiplexer. It will receive 4 data, one data from arithmetic, another data from logic circuit, another 2 data shift right and shift left data consider here. Okay, so now you see very simple way it is mentioned, and this either 0, 1, 2, 3, it will defined through 4 that is 2 selectors, S2 and S3. S2 and S3 defined 2 selectors, 0, 0, 0, 1, 0, 2, sorry 0, different values. We know that is either that is 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 0 1 is 1 position, that is 2 position and 3 position. Okay. If 0 0 0 means 0, if both S2 and S3 is 0, then what happens? So both are 0, then 0 position, this position means arithmetic operation will start. What are the arithmetic operation? Different arithmetic operation will start, and that will receive the data from AI and BI. Okay, AI and BI data it will receive, and a number of operation we can consider. Similarly, 0 1 0 1 means 1 position is a one stage of logic circuit. It will receive only one stage logic circuit here 1. Okay. Next 2 1 0 2 means only shift right data it will consider only shift right data, and 3 here 3 is a shift left data, you see shift left data. So in this way this multiplexer choose either arithmetic circuit arithmetic operation, or that is a logic operation, or shift right or shift left operation. So it is designed in this way, very simple way we have to we can design in this way, and one output we can get it. Okay, according to the operation means according to the selection variable, one output we can get. So in this way, so 3 component will be considered to make a one stage of arithmetic, logic and shift operation. Okay. So now we see which one or how it will operate. This is the design of that one stage logic arithmetic logic operation or logic and shift unit, but how it will work, that is important. How it will work according our inputs, that is AI BI, or either go through arithmetic or logic circuit or any other. Okay. So how it will work according to this some function table, that is important. We will see how it will work. Okay. Now I will show you how it will work. Very simple way. Now we see here first some operation select. How many operations you see? Sorry, how many operation selection of variable, selection operation S0, S1, S2, S3, 4 selection variable we consider. So here I mention that is 4 selection variable, S0, S1, okay, S0, sorry, S3, S2, S1, S0 and Cn. Okay, these 5 Cn, so total 5 variable will consider as operation selections. Okay, whenever put some value, then automatically what kind of operation will consider or will get it according to this particular design, either arithmetic or logic or some shift, which operation will consider based on that different selection variable. Okay, we will see how it will operate and what kind of output we can get it. That is the important part. Now we see very simple way we will consider. Now S0, sorry, S2, S3, S2, S3. Suppose S2, S3, 0, 0. 0, 0 means which one? Arithmetic. Because it is select through 0. 0 means arithmetic. Now see, if it is 0, how many operation we can consider? 0, 0. Okay. If it is 0, 0, arithmetic is there. Obviously, we know that arithmetic is there. Then it depend on that. If this is 0 arithmetic, again that arithmetic also defined through S0 and S1, which operation. Okay, and arithmetic operation we have already discussed in the last operation based on that certain value, that is D is equal to A plus. Okay, we have already discussed that part. D is equal to arithmetic operation, very simple example. D is equal to A plus Y plus Cn, that very standard equation whenever you go through any arithmetic operation. Okay, and Y is defined through B variable defined through Y with a certain number of multiplexers. You can see that arithmetic operation how design. Okay, that is, and calculated different ways. Whenever Cn is 0, for example Cn is 0, then what happens? A plus B value is like this, and sometimes B value is Y value is B complement. Okay, in that case we can write A plus B complement. Okay, and if Cn is 0, sometimes A plus b complement plus 1 whenever Cn is 1. Okay, in that case we know that b complement plus 1 means minus b, that means a minus b. Like this different operations we have already discussed for arithmetic circuits. Okay, one lectures also I also explained. You can also see that videos how this particular standard equation define different arithmetic operations. Okay, now we will see how it is defined. So if we go through S3 S2, that is only arithmetic operation we will consider. Another is S0 S1. Now we will check S0 S1, it is 0 0. Okay, if it is 0 0, another is Cn 0 initially, Cn 0. Okay, in that case what happens if C0, in that case S0 S0 0 S2 0, only 0 0, this S2 S3 0 means only arithmetic operation we confirm. After that S0 S1, if we go through that and Cn is 0, then what happens, what is the functional value? If is equal to, you see if is 0 0, I will tell you one simple example. If you see if S0 0 and S1 0 both are 0, then b value not consider. See, this b value not consider, one concept is there, b value don't consider. Okay, in this logic, so b value not consider. Then what happens if b value not consider means b is 0. Okay, b value not consider means b is 0. In that case what you will get, that is a plus 0, and another is Cn is 0. You see Cn is 0. Okay, that means b is 0 and Cn is 0, so total a. So functional value is a. Okay, d is a, d means arithmetic value a. So in that case what happens, we write simple a, we can write simple a. In this case what happens, we can write that is a transfer a. Okay, we can write a transfer a, very simple way. Similarly again 0 0 0 0 1, because Cn always change 0 1 0 1 0 1 0 like this. If Cn is 1, then what happens, 0 0 means b value is 0. You have to remember this one, and some logic also there. Okay, you have to remember b value 0 for S0 is 0 and S1 is 0. 0 0 means b value 0, y value not active. Then in case here what happens, f is equal to b part is 0, Cn is 1, so a plus 1, because according to this you see. Okay, d is equal to a plus y, b is 0 plus Cn 1, so a plus 1, so a plus 1, because Cn is 1, b is 0, y part not active, so b is 0, so a plus 1. So if a plus 1, what you call, that is increment. Okay, we can write increment a. Okay, that is a increment a. Next, here also we can also write other like 0 0. Okay, now we see that is again 0 1. Now we say 0 1. If it 0 1, one stays, suppose one value, then b will add. What is the b value? We'll see. Next it is 0. Okay, it is 0 because Cn is 0. Cn value always 0 1 0 1 0 1 based on that other value. So if here is b, simple b we can consider. Then what happens, Cn also 0. So obviously f is equal to a plus b also consider. Okay, that is a plus b. But Cn is 0 because a plus b plus Cn is 0. So simple the addition number we can tell as a addition. Okay, we can tell as a addition. Similarly again 0 0 0 1, it is 1. What you call, f is equal to a plus b, because of the 0 1 means b. Again 1 means 1. Then what happens, addition with carry we can write, because 1 is carry, addition with a carry we can tell as a addition with a carry. Okay, next similarly here is, since it is 0 0 means arithmetic 0 0, here is 1 0 1 0, here is 0. Okay, If it is 1 0, be careful that logic is there. If it is 1 0, that is B complement. If it is 0 1 is only B. If it 1 0 is B complement. Then what happens? F is equal to A plus B complement and C in 0. Okay, simple, C in 0. Then what we call that is, it is a subtract concept with a borrow. We can write subtract with a borrow. Subtract with a borrow. Okay, कौन subtract with a borrow. Okay, this is the basic concept. Next, again we will see it is a 0 0. Okay, here will be 1 0, here will be 1. So F is equal to what happens? A B complement. Okay, A B complement plus 1. B complement plus 1 means obviously A minus B. You can write A minus B. Okay, since A minus B, what you write is simple subtract. Okay, simple subtracts or subtraction also we can write subtraction. Okay, very simple way. Next arithmetic 0 0 1 1. If you 1 1, here is 0. If you 1 1, okay, if it is 1 1, then last we have already discussed. If it is 1 1, then minus value we can consider. If it is 1 1, S01 is S01 S1 1, this is a minus value we can consider. So F is equal to A, okay, 1 value. It is a 1 minus 1. We can consider minus 1. If it is 0, C is 0, but here is a 1 1 means it is a minus 1 value. Just consider, we have already discussed that part. Whenever 1 1 value, logic value is 1 1, that is a minus 1. We have already discussed. Okay, in that case what happens? Minus 1, it is C is 0. Then what happens? What you call that is a decrement. Okay, decrement. Okay. Decrement of A, this one. Okay, next, if it is 1 1, again 1, that is A is equal to, means A minus 1, 1 1 means minus 1, A minus 1, here the plus 1, obviously it will be, that is simple A, that means transfer A. Okay, we can define it is a transfer A. Okay, so this is the basic concept regarding on this. You see, all part is over for arithmetic, because here 0 0 0 1 1 0 and 1 1, all arithmetic is over. Remaining part means arithmetic, after arithmetic we will see which part there is a arithmetic completion. Then what happens? Logic part. How to get it? Logic part, if it is 0 0, you see, if it is 0 0, 0 part is over. 0 0 means here S2 S3 is 0, you see all are 0, 0 part is over. Next, then what happens? Because why it is? Because here 0 0 0 1 1 0, all part is over, so arithmetic is over. Next, come to 1, means S2 S3 is 1 0 1. Now we see, we can consider that part is 0 1. Now very simple, 0 1. Okay, if we go through that 0 1, then what happens? What will do? Okay, if it is 0 1, then same thing we can consider 0 0. Okay, if it is 0 0, then what happens? We see that logical part, if it is 0 0, here what happens? No C in value, because I have already told, if you arithmetic, then carry out data can be considered. If you logic, no carry. Okay, in that case what happens? Don't care condition we can use like this, don't care condition. Then if is 0 or 0, then we consider AND operation. Very simple, is A and B. Okay, A and B. So AND operation we use. In this case, AND operation we use. Okay. Similarly, if we go through 0 1. Similarly, how many cases? Logic case 4 cases we consider, because 4 logic. Okay. Similarly, 0 1, here is 0 0. Next is 0 1. here see any or carry any no don't carry condition. 0 1 is equal to A or B. We can write or B. Okay, A or B. Okay. Next, similarly 0 1 here is 0 1 completed 1 0. 1 0 means 2. 2 means next exerg. Okay, here is don't carry condition. F is equal to that is exergate. Exer with B. We can write exer operation. Okay, function is a exer operation. And similarly another is other part also we can write very simple way, that is 0 1 1 1. Okay, if it is 1 1 then complement. Okay, here we will consider that is a complement. F is equal to A complement. We consider that is a complement. That means a complement of A. We can write complement of A. Okay, in this way we can write. So we see is a 4 part logical part. This is the logical part. You see very simple way. This is the logical part. Logical. Okay, this is a logical part. I say logical part. Okay, and the first part is a arithmetic part. Okay, arithmetic part. Okay, first part is arithmetic. You see very simple way. First part is arithmetic, second one is logic, and next is a shift. If we go through shift, you see first 0 is come over, 1 is over. Next 2 means what 1 0. Okay, 1 0 is 2. 2 is what you see shift right. 3 is shift left. Shift right, shift left. That part we can consider. How? You see how it is defined. Very simple way I will define here. Okay, now here is what you write 1 0. You see it is 1 0. If it is 1 0, you see there is no relation S2 S0 S1. If you 1 0, there is no relation S0 S1 and a scene for shift operation, any shift operation, no relation. So in this case it is a cross, all are cross value. Okay, and it is cross value and a function data we can go through shift, that is what right, shift right of A, shift right of A, or we can write shift right A. Okay, shift right A into F, shift right of A into A, and the last one is 1 1 because it is 2 and here 3, it is 1. Same thing, it is shift what you write shift left A, right shift left A into F. Okay, so in this way different functional value we can design as per this particular one stage operations or one stage logic design. Okay, one stage logic design we define in this way. The very simple way we can also see how it is create or how it is operated for different functions or different components, or how different functions are generated as per this one stage logic circuits, and different operations either may be that is mathematics operation, logic operation, or shift operation, how it is defined. This function table is very useful to that is identify which operation need to operate. Okay, I hope all of you understand this particular concept, that is a one stage of logic, arithmetic logic and a shift unit. Okay, so thanks to all. Please subscribe my channel, and if you want to give comments you can give. Okay, thanks to all.